Yeah, thank you for the introduction. Hello, what a nice attendees. Thank you for being here and standing to the end. So today I'm very pleased to guide you through this presentation to share with you some of y'all's understanding of the power GaN market. And maybe it will be a multi-billion market in the coming 5 years. So let's see. Yeah, so I will start with some overview about power electronics in general, and then I will dive into the power GaN market trend with, of course, closing with some remarks at the end. Yeah. So why bandgap for power electronics? So actually, when it comes to make a choice for power electronics technology, it's really about what I call a holistic approach. Means there is a lot of parameters that need to take into account. It can be from technical point of view, societal, environmental, and even sometimes geopolitical aspect that can influence the choice of the technology to use in the power electronics. But it all starts with the application requirement, of course. So, for example, for a consumer fast charger, of course, here the end user needs something compact, lightweight, that can be put in the pocket, charge fast. So that's really some requirements. But if you look at the automotive, so here we need extended range, we need fast charging for the car. So it's another type of requirements. And for some industrial application, here really we need for reliability. A system that will work like 24 hours, 7 days a week. So it's different requirements. So those different requirements will for sure drive for different system characteristics, different topology to be used, different type of test, different type of packaging, and then it comes to the device characteristic, of course. So here, as you can see, there is a multitude of choice for the power electronics in terms of packaging, in terms of voltage ranging. And if you come to GaN, silicon carbide, and silicon, you can see here the famous radar chart showing all the technical attributes by material. And for silicon, we know it's the legacy technology, so it has been here for more than 60 years. It's still doing good enough. But we see now wide bandgap material coming with better technical attributes like silicon carbide operating at high temperature, supporting high power application, and then gallium nitride switching fast. So here it brings compactness, it brings high efficiency. So that's really to give an overview about the choice of technology for power electronics. So in terms of market, as I said, so silicon is still doing good. So I think the bottom line in the power electronics industry is that when the silicon can do the job, the silicon will be used. And most importantly, it's because of the cost, of course. So, but we see also wide bandgap taking more and more share, starting actually from 2017, 2018, when the SiC was first adopted in the EV by Tesla, and then GaN adopted in the fast charger. So they start to take more and more share to be by 2028 around 25% share expected for GaN and silicon carbide. And it will go even beyond 30% by 2029. But you can see that the bulk of the market is still taken by the silicon, and it's also increasing. So what about power GaN market? So I think you all agree now that GaN fast charger is becoming established application for the power GaN device. So it's like a commodity to go to any retailer, you can go to Amazon and just purchase a 65 watt charger, a GaN charger. So it started first, as I said, in 2018, 2017, but now you can see almost all the top consumer OEMs have already released GaN charger and using GaN in their charger. And this trend is also increasing. So we see For example, increasing adoption in the high power power supply. So now we speak about like more than 100 watt up to 300 watt consumer fast charger, which is huge. Charger that enabling like 0 to 100% charging in less than 10 minutes. So that's really pushing toward more adoption of GaN, of course. And another trend is also the all GaN charger. So here we speak about a consumer charger that it's made only by GaN device, which is not the case now, but you can see like it gives the potential of usage of up to 4 devices per charger if we take into account the 650 volt and less than 200 volt in the second stage. But all this said, though, meanwhile, like we have a great success here, but the consumer market is still like a cost-sensitive market. So already we start to see like the cost and the price pressure on the GaN device to be used in this application. So that's really affecting the margin. So to get to the multi-billion market, there is a need to have other growth engines besides consumer, and that's what we'll see in the coming slides. So of course, so we see automotive powertrain, so as one of the main driver. So now we have explained that consumer has been a good and nice application for GaN. It enabled fast time to market, getting volume, getting first revenue, but then what's next? So next it's really the like few kilowatts of application, tens of kilowatts. I can tell you that this is not new for GaN, so efforts and R&D and design-ins project has already started, let's say, a decade ago, as you can see from some of this market player, tier 1s and OEMs in the automotive sector. So we have seen like DC-DC, onboard charger, and even inverter project to see how the GaN can be adopted in this area. So we see like a really accelerating pace toward releasing a commercial GaN-based system, and I think Infineon has already stated that they are going to production end of next year. So OBC, it will be really the let's say as a kind of a sweet spot, first application, high volume application for GaN in the automotive. But an important thing to say also that GaN, it's not only for powertrain application when you speak about automotive. So this picture show like the widespread of application that GaN can be adopted in automotive. Because when you speak about silicon carbide, it's directly we speak about like powertrain, traction inverter. It's true that that's the high dollar content in a car, but GaN can reach more application than that. For example, I can mention LiDAR. LiDAR is already a high volume application for automotive. It's already well adopted, especially with the autonomous vehicle trend. So already like millions of GaN chip, 100 volt, are being shipped like for LiDAR drivers, and there is other potential application like auxiliary power supplies. We have seen like power integration, and the other also major player are pushing for that. Of course, for infotainment, so GaN is already adopted for charger. Why not for in-cabin for charging, also for Class D audio in the car. So there is a multitude of application that can bring like the TAM up to, can you see, like we made like a RAD calculation, and just counting all this application, you can reach like more than 90 device in count per car. So that's impressive. So one more application, of course, is data center. So with the AI trend, so I think we all heard this announcement about NVIDIA, Blackwell, and more to come, GPU generation. So that needs higher than 1 kilowatt of power consumption. So that will draw a lot of electricity from the power distribution in a data center. And of course, it will need a higher power system, and also a lower form factor, because you need to keep the size smaller, even increasing, so the power density should increase, and higher efficiency. So here I'm showing the like a typical power distribution for a data center, and just to show where GaN can be adopted. So here it's the power supply unit, and also we see GaN in IBC, so intermediate bus converter. So that's what has been presented by Texas Instruments this morning. So GaN can be there, so it's already having a strong value proposition. So GaN, I think we all agree that can bring efficiency, high power density. So that's efficiency means like lower power consumption in terms of electricity, so lower losses. So it will also increase the profit for data center owners. So it has a strong value proposition, and it can reach already very high power density. So that's 100, but we have also seen recently from Navitas 135 watt per inch cube power density for a 4 kilowatt power supply. So that's really a strong and sweet application for GaN. So as you can see from the logos, there is already several players that are involved, and I can tell you that there is already commercially available GaN-based power supply. For example, from Bell Power Solution, they have already the offering, and you can go and buy your GaN-based power supply. And more players are getting involved, like Lightion and Delta and others. So it's really, we see it like one of the next growth engine for power GaN to bring it to multi-billion market. So that's it for market adoption. So what about ecosystem? So here, because I'm in Taiwan, I wanted to make kind of an extraction about what's happening and how far the power GaN ecosystem in Taiwan is going. So as you can see, the brief answer is that Taiwan ecosystem is well established for power GaN. So we can see like at different stage of the supply chain, different level, we have like established major player. Most interestingly, of course, is the foundry business and the foundry for power GaN. It's with TSMC, of course, and more players coming to the business, like Vanguard, PSMC, and other foundries. So, of course, there is a lot of startup companies in Taiwan trying to enter this market and to get their opportunity and their market share. So, and in terms of end system, interestingly, we see more like power supply maker and ODM, but maybe less for automotive, which might come in the future, but that's really from Delta and Lightion that they are the two major players that are even pushing for this power supply unit adoption for data center. So just to give you a final overview of the market, so in 2023, so the market is still really driven by the consumer power supply. So 80 to 90% of the market are coming from this application. But in the coming 5 years, we foresee the GaN to penetrate to high power, high-end application, especially like EV, HEV, and OBC and DC-DC. And penetrating also data centers, so that will bring the market to like a multi-billion, 2 billion plus market. In terms of technology, for sure GaN on silicon will remain like the main technology platform, but also GaN on sapphire, it's being also adopted. And we see, I think with Vanguard presentation, also GaN on KST. So we have seen recently first adoption of GaN on KST in a charger, so what has been also showed in Vanguard presentation with the Lake Semi charger. And looking even further than 2029, we don't see like any challenge for GaN with more maturing, more price erosion to get really into more broader application, industrial for PV, for industrial motor drive, PV microinverter, and maybe penetrating also more powertrain, why not inverter applications. So, and in terms of technology, we don't see like stagnation in terms of innovation. So there is still room for innovation in GaN. Why not GaN on GaN vertical, and starting also emerging new type of ultra wide bandgap material like gallium oxide and diamond. So, and that's really we track at Yole. So this presentation has been based on, of course, on our product. So we have our monitor quarterly update product. So we track a different market, different application, different technology. So specifically here, it's we have the PowerSeek and PowerGaN, of course, compound monitor, and then we have out-of-the-shelf report, so yearly update, and you can see like we have different topic from power GaN, power SiC, and more high-level approach like status of power electronics and automotive power electronics. So with that, I thank you for your attention, and I'm happy to answer your questions.
Okay, open to a question right now.
Hi, thank you for taking the question. Can you give us some understanding of how quickly GaN will be adopted in data centers, and who's got the design wins as far as you're aware of them?
I didn't get the question, sorry.
Sorry, how quickly is GaN being adopted in data power supplies?
Mm-hmm.
And who will be the, who's got the early design wins? Any indications there?
Mm-hmm, mm-hmm. Yeah, so that's a very good question. So in terms of already commercially available product, so it's already in the market, so you can go and buy GaN-based power supply. After how fast, I think we need to understand that this market are still like conservative with long development cycle and replacement cycle, of course. So those systems are meant to work for like 15 years range. So it's kind of a slow adoption market, but especially with the AI and going to like higher than 3 kilowatts power supply, we see accelerating pace for the adoption. So we really, in our forecast, we foresee a major adoption in the coming 5 years. So it's not in the 10, 15 years ahead. So yeah.
Any more questions? If not, let me ask one question, okay? I think today we have a lot of talk about this low voltage, below 100 volts type of application, and especially the GaN and also the silicon. The Infineon is another case, right? They have all the recipe to provide a solution. So from your point of view, for the real penetration rate for GaN into this market to basically coexist with the current silicon technology, do you think what is the future, or what is the real competition there? I mean, the pricing or the performance? Because I can see the Infineon come up with a very new the Optimos, right? Mm-hmm. Competing with the GaN. Mm-hmm. So what is the opinion on that?
Yeah. I think generally it's really pricing. That's what's making challenging for low voltage GaN to penetrate. But we see already GaN taking off in some specific application where the performance is really matter. I mentioned, for example, the LiDAR application. Here it's more for driving the lasers, and there the GaN is really making the difference, having high switching speed to get better resolution for the LiDAR. So there is some kind of niche application nowadays that GaN can really make the impact in terms of performance. So there the price is less, let's say, impactful. But generally speaking, it's really a price-driven decision in the low voltage domain. That's why we don't see, like, even if you take the share between medium to low voltage for GaN, low voltage is still really small. 20 to 30% of the device market for GaN are taken by the low voltage. But of course, GaN device pricing are getting lower, so there is really a strong price erosion for that. And I assume when we reach really a price parity generally, so the GaN will be will make better choice for GaN instead of silicon. So that's yeah, kind of overview of that. Yeah.
So, any more question?
We know your company has published a lot of good information related to silicon carbide, but why you didn't talk much in this presentation. Do you have any, what kind of outlook for you compared to GaN and silicon carbide?
Yeah, silicon carbide, this was another interesting topic that we also analyzed at Yole. So, but just the choice was made to focus on GaN for this presentation. But we have also a lot to say about silicon carbide. As you can see from the one slide that I showed, silicon carbide now it's like in the 2 billion order of like as a device market and reaching maybe 9 to 10 billion by 2029. So we have a lot to say on that, but the focus for today was more GaN. So okay.